Well, warm welcome. Thank you for joining us. This is Math from the Void. Math coming at you from pretty much out of nowhere. I'm just a voice speaking knowledge to you, working you through the AP Calculus exam to get you prepared for it. Today we're looking at a question from 2007, a bit more modern times. And this is from the BC exam, question 4. So there is a BC component, but if you're an AB and you're still watching, just know that only part C requires you to use a BC method. Questions A and B can be perfectly answered if you have a strong understanding of calculus AB. Let's talk strategy as we analyze this question. They've given us a value of f, and they've given us the derivative. The derivative is this product here. Since the derivative is a product, it will not be easy to take the antiderivative unless you've done Calc BC. But this initial condition will definitely play into that when we take the antiderivative. Let's read along with part A. Part A uses a very important phrase here that I want you to be intimately familiar with. Equation for the line tangent. When I see that phrase, I immediately stop what I'm doing and I write down this formula. This is the point slope equation for a line. And it's the most common equation of a line that you're going to use on the AP Calculus exam. The point slope version requires three things. It requires an x value, a y value, and a derivative, which is the slope here, m. They've given us a point e comma 2. So they gave us the x value and y value. So far we have the following equation. Y minus 2 equals m times x minus e. Let's find what the slope is by plugging in the x value e. F prime of e, based on the definition of the function, is e squared times ln of e. Ln of e is just 1. So this is simply equal to e squared, which means the full equation of the tangent line at the point is y minus 2 equals e squared x minus e. And feel free to leave your answer in this format. There's no need to put this in a y equals mx plus b or slope intercept format. This is adequate. Part B. Is the graph of f concave up or concave down? Well, let's take a derivative, shall we? If they want to know about concavity, we need to understand the second derivative. And since the first derivative is a product, we're going to have to use the product rule for the second derivative. I usually lay things out like this so that we remember to do the derivative of the first. That's what the double lines are for. And we leave the second one the same. Plus, leave the first one the same, single line, times the derivative of the second one. That's 1 over x. So this is going to give us 2x ln of x plus x squared times 1 over x is just x. And therefore, I can actually factor this a little bit. Take the x out, and we're left with 2 ln of x plus 1. Well, let's see when this is equal to 0. After all, it's asking if the graph is concave up or concave down from 1 to 3. Let's use a chart to analyze this. Of course, this is equal to 0 when x is simply 0. But what about this? 2 ln of x plus 1 is equal to 0 whenever ln of x is equal to negative 1/2, which means x equals e to the negative 1/2, or 1 over the square root of e, which I'm not too sure of off of the top of my head. I want to say that this is something like 0.7. Yeah, if I had to guess, it's something like 0.7. It's not particularly important about that, but it is slightly important about that. Let's look at the chart. We have, of course, the factor x, and then we have the factor 2 ln of x plus 1. Maybe I should move some of this stuff. When are our factors equal to 0? Well, we have one 0 at 0, and then we have another 0 at e to the negative 1/2, which is 1 over the square root of e. You know what the ln function looks like. The parent function looks something like that. So we know that it's negatively valued to the left of its 0, and it's positively valued to the right of its 0. So overall, the second derivative is going to be 0 at x equals 0 and at x equals e to the negative 1/2. It's going to be regions of positive, then negative, then positive. And because we know that e to the negative 1/2 is definitely less than 1, remember the interval of interest is from 1 to 3. We know that e to the negative 1/2 is definitely less than 1. How do we know that for sure? Well, e to the negative 1/2, which is 1 over the square root of e, I claim that it's less than 1. And this should make sense because if I multiply both sides by square root of e, the square root of it, is definitely more than 1. And if you don't believe me, square both sides and you'll get that e is definitely bigger than 1. So its square root has to be bigger than 1. Therefore, from 1 to 3, we can confidently say that the graph is concave up because f double prime is positive on the interval from 1 to 3. So we can say the original function, f of x, is concave up on 1 to 3. There we go. We've justified it with the chart. Great. Now let's tackle this CALC BC portion, which has us use anti-differentiation. They even give you a huge clue there to find f of x. Of course, if we're given f prime, the way to find f is to take an antiderivative. So we're going to have to use this initial condition as well, f of e equals 2. And we're going to have to use integration by parts. So we know that the derivative, or rather the integral of the derivative, is equal to the original function plus some constant c, and that's where this initial condition is going to play a role. F of e equals 2. So I use the detail model when integrating by parts to determine what is my u and what is my dv. My u shall be ln of x, therefore my du will be 1 over x dx. My dv is x squared dx, and my v is therefore 1/3 x cubed. Okay, let's use the integration by parts formula. It says that the integral of v of u dv is equal to uv. So that's going to be 1/3 x cubed times ln of x minus the integral of v times du, which is the integral of 1/3 x cubed times 1 over x dx, which is simply x squared dx. So I still have a little bit of integration to do. One more power rule here, and this is going to turn into 1/3 x cubed ln of x minus 1/9 x cubed plus c. And this is my f of x. So now it's time to use the initial condition that f of e equals 2. So let's plug in e. We're going to get 1/3 e cubed times ln of e. Ln of e is nice, it's just 1. Minus 1/9 of e cubed. Whoa, my 9 went away. Plus c. Well, this is simply going to be 1/3 of e cubed minus 1/9 of e cubed, which is 2/9 of e cubed, plus c. This all equals 2. Therefore, c is equal to 2 minus 2/9 of e cubed. And that tells me that my original function is therefore equal to 1/3 x cubed ln of x minus 1/9 x cubed plus 2 minus 2/9 e cubed. And that is my original function f of x. If you don't believe me, plug in e and you should get 2. Additionally, take a derivative and you should end up with simply x squared times ln of x. I'm not going to do that for you now, but if you had time on the AP exam, you might want to do that to check and make sure you're getting full points. So the final part of this question was the BC component. A and B were very approachable from anyone in Calc AB or BC. That'll do it for me today. This has been fun. I hope you learned something. I'll see you next time in the void.